All right, Advanced Math 8, here we go. We got lesson 7.1.2, conditions for triangle congruence. What we're going to see in this section is, you know what, it's kind of a pain on every single triangle to prove every single side is congruent and then prove every single angle is congruent. That's a lot to prove congruent. You got to prove all three sides and all three angles. Are there any shortcuts? And yes, there are shortcuts. So we're going to look at shorter ways to prove triangles congruent without proving every single side's congruent and every single angle is congruent. Because actually, you only need to prove three things are congruent. And we're going to look at some of those three things that you need to prove congruent, and instead of proving six things, you know, three sides, three angles. So we're going to go back to what we were doing the last time. So we're going to look at these two triangles and prove they're congruent by the Pythagorean theorem and by the triangle sum theorem. So let's start with the Pythagorean theorem. Let's call this side B over here. All right, so Pythagorean theorem, I would say 28 squared plus b squared equals 35 squared. So 28 squared plus b squared equals 35 squared. Okay, so 28 squared is 784. And 35 squared is 1,225. Okay, I'm going to subtract 784 from that. And I get b squared is equal to 441. I think that's a perfect square. So now I'm going to take the square root of both sides. And then I take the square root of 441. And it is a perfect square. It's the perfect square of 21. So this side is 21. All right, let's see if we have sides that are matching up. I know this side corresponds to that side because they're both 21. I know this side corresponds to this side because they're both 35. Now we ask ourselves, does this side correspond to this one? Are they both 28? Well, yeah, they are. We already know that, but we're just going to prove it. We'll call this one A. So we're going to do A squared plus 21 squared equals 35 squared. So 21 squared is 441. 35 squared is 1,225. If I subtract 441 from both sides, I get a squared is equal to 784. And then if I take the square root of that, lo and behold, we get a is equal to 28. So this side over here is 28. So now we know that this side corresponds to this side. So this side and this side match up, this side and this side match up, this side and this side match up. Using the Pythagorean theorem, a squared plus b squared equals c squared, we have proven that the three sides are congruent. But in order for the triangles to be congruent, we said that the three sides have to be congruent and the three angles have to be congruent. So let's see if I've got anything on these angles. Well, I know that this angle here and this angle here are both 90, so they are congruent to each other. Now I've got this one's 53.13 and this one's 36.87. So those ones aren't matching up. So I'm going to have to pull out the triangle sum theorem to see if it works. All right, so let's go ahead and do this. So let's do this one right here. I'm going to call this, oh, that's angle N. So I'm going to say angle N, the measurement of angle N. So the measurement of angle N plus 90, because that's this angle here, plus 53.13 has to equal 180 degrees. So 90 plus 53.13, so this is measurement of angle N, plus 143.13 equals 180. Now I'm going to subtract 143.43 from both sides, and what do you know? I end up with 36.87. So now I know that this angle right there is 36.87. So this angle right here, where's my pink? So this angle right here is matching up with this angle right here. So the 90 goes with the 90, 36.87 goes with 36.87, and if you do the math, this 53 matches with this one right there. So now we have all of our angles are congruent and all of our sides are congruent. Now we can write our congruence statement. So remember, the first triangle, it doesn't matter which order. So I'm going to do MNP. Congruent to triangle. Okay, now at this point, order does make a difference. So which angle does M correspond to? It corresponds to Q because they're both the 90-degree angles. So Q has to go first on the other triangle. Next was N. This is the 36.87 angle. So that corresponds with S over here. So the second letter has to be S. Last one's P, that's the 53.13, and R is also 53.13. So R. Now watch what happened to the sides. MN had 3 tick marks on it. QS also had 3 tick marks on it. NP had 2 tick marks on it. SR also had 2 tick marks on it. And then finally M and P at the first and last had 1 tick mark, and QR first and last had 1 tick mark. Everything is in order. That's how you write a that's how you write a congruent statement. All right, transformations. Okay, so I know that Q and M go together, so I would translate this until Q's on top of M. So I'm going to translate triangle RQS so that Q is on point M. So I'm going to move this to here, so it's still kind of not in the right order because our triangle would basically look like this over here. So next, I would probably rotate. So I'd spin this triangle. So I've moved this here, and now I'm going to spin it until S is at where N is at. So I'm going to rotate triangle RQS, and I'm going to use M as the point of rotation. So that S moves up to where N is. Now look what happened. Q and M are on top of each other. Q and M. So I'm matching up those two. Next, I'm matching up S and N, not M, N. So the second thing I did is I matched up N and S together. And once I did that, the two shapes are looking like this now. So I moved Q to M, then I spun it, so this is now facing this direction. And my last thing is going to reflect it so that over here where R is supposed to be, it'll be on top of P. So the last thing is I reflect triangle RQS, and I'm going to reflect it over NM. And that will match up R over here to P when we do that. And this is actually what you could do almost every single time. You could translate one point onto top of another, rotate so another point's on top of another, and then reflect. And those three series of transformations will always get you the two triangles on top of each other. I think your book has a pretty good way to do this on the practice problems. Like it's got like a computer generated thing where you can actually see you moving it all around, which is pretty cool. All right, let's talk about some shortcuts. Okay, so can we prove two triangles congruent if all we know is their angles? Okay, so if I know, I'm just going to start with something really simple. I've made a equilateral triangle. So this is 60, 60, and 60. Okay, what if I had another triangle that was equilateral? Would it be congruent? And the answer is no. If I've got another triangle here, and let's say this one was also 60, 60, and 60. So here I've got, let's say all these sides are 5, and all these sides are 3. Okay, so these two triangles would not be congruent to each other. Now they have all three angles. They've got A, and A. All three angles are congruent to each other. But that's not enough information to prove that the two triangles themselves are congruent, because these ones are actually similar, right? Because I've basically taken this one and shrunk it down. The angles stayed the same, but the sides are now different. So that's not enough. Just knowing the angles are the same is not enough information. We can see that this is a scale factor of 3 to 5. It's just not working. So knowing the angles are congruent is not enough information to prove the triangles are congruent. To prove so that's not enough information. Just knowing that they have the same angles, not enough. You're going to need more. Okay, what about angle aside and an angle? So this is the first one that does work. Let's say, I got this, here we go. So this is 3.3 centimeters. And this one's 3.3 centimeters. So both of those are 3.3 centimeters. Let me take out a tool here called a protractor. And I'm going to make let's just make a 90-degree angle right here. So I'm going to make a 90-degree angle with my protractor. All right, so there I made a 90-degree angle. I'm going to go over here to this other side and make a 90-degree angle. So there's another 90-degree angle. Okay, and then I'm going to, on the other side, make a 40-degree angle. Let's make a 40-degree angle. You guys can just watch this. So from here to here, we're going to call this a 40-degree angle. So that'll be 40. And then we'll do the same thing on this side. I'll make a 40-degree angle starting over here. .40 degrees would be about right there. So the question is knowing just these three pieces of information enough? So I've got an angle, I've got a side, and I've got an angle. And notice I didn't mark off where they crossed. I'm just saying, is this enough to prove with just an angle, a side, and an angle, side, is that enough to prove the triangles are congruent? And the answer is going to be yes, and here's why. So I've got this side, and they're the same. Well, this angle here locks the other side, because if this is 90 degrees, this side has to go in this direction for the triangle. It's locked in place. Now, the distance isn't locked in place, but where the side is locked in place. And so the same thing happened over here. This 90-degree angle has locked this other side in place. It can't move. Then over here, this 40-degree angle has locked this pink side in place. And then over here, this 40-degree angle has locked this pink side in place. They're going to have to meet at a spot where it's going to be the same. They're going to end up meeting at a spot that will make these two triangles exactly the same, because this side got locked in place by this angle, and this side got locked in place by this angle. These two triangles are going to have to be congruent, even though I don't know what the length of this side is, and I don't know what the length of this side is. But since these angles have locked those sides in place, there's only one place that these points can meet, and they're going to be the same distance. So if you've got angles with a side in between, and they match up with angles and a side in between of the other triangle, that is enough to prove those two triangles are congruent. So here's what we say. If two corresponding angles, so these two corresponding angles, these angles correspond with these angles, and the included, so included means it's the side right in between them. So the included side, so I've got angles and the included side, of two different triangles are congruent, then the triangles are automatically going to be congruent. So if I've got two angles with a side in between, I don't need to prove this side and this side and this angle. This is enough to prove those two triangles are congruent, because these angles are locking those sides in place and they can only meet at one spot. So this angle locked that side, this angle locked this side, they have to meet right there. There's no other place for them to meet. So we would have to say these two angles, these two triangles are going to be congruent to each other because of angle side angle congruence. So this is a shortcut. I only have to prove three things congruent instead of all three angles and all three sides. All right, last page. Took a long time to get through that one page. Okay, so here we go. Given angle H is 68. Okay, we better write that down there. So angle H is 68. Okay, angle F is 25. This one's 25. Angle J and angle G are both 87. So J is 87 and G is 87. IJ and FG, the length of IJ and the length of FG are both 13. So IJ is 13 and FG is 13. So FG is 13. Prove that the two triangles are congruent. Well, here I've got angle, side, angle, but it doesn't match on the other one. I've got 87, 13, 87, 13, 25. So what I would need to prove is that this one right here is 25. So we can use the triangle sum theorem to prove that. So we've got 68 plus 87 plus this one should equal 180. So I'm going to say measurement of angle I plus 68 plus 87 equals 180, because the three angles always have to add up to 180. All right, 68 and 87, that's 155. So measurement of angle I plus 155 equals 180. Subtract 155, and the measurement of angle I is equal to 25. Ah, yes, it is 25. So what do we have here? We've got angle, side, angle. And over here, we've got the same 87-degree angle, the same 13 side, and the same 25-degree angle. So we've got angle, side, angle. The side's included, meaning it's right in between. And we've got angle, side, angle. The side is included, it's right in between. So we have just proven the two triangles are congruent by angle, side, angle. All right, next one. Angle, angle, side congruence is proven by angle, side, angle congruence. All right, so looking at that previous problem, we were looking at it and we're like, okay, so we had to have this thing here so we could have angle, side, angle. But would angle, angle, side be enough? And the answer is going to be, of course, yes. So what we've got here is we've got 68, 87, 13. So that's angle, angle, side. But over here, we're missing the H, right? So let's go ahead and find out what this other angle would be. Well, it's 87.25. This one's 68. And this one's 68. So this one is actually also angle, angle, side. So angle, angle, side is actually the same thing as angle, side, angle, because we've got angle, side, and then this angle's 25, angle, side, angle, this one's 25. So since the triangle sum theorem says that all these angles are going to be the same, we can also use just angle, angle, side to prove something, because it's the same thing as angle, side, angle that we had earlier. So here earlier we were using angle, side, angle, but since triangle sum theorem says that all of these add up to the same numbers, that we'll always have to have 68 up there, angle, angle, side works just as well. They're actually the same thing. So what we call it when we do angle, angle, side is that it's the two angles and the non-included side. So we can see that this side is not between those two, so we call that the non-included side. So angle, angle, side works just as well. All right, so we're going to state whether these two sets of triangles are congruent or not congruent. If they are congruent, then we're going to write a congruence statement. All right, so I've got 40 degrees here. I've got 40 degrees here. That's an angle. I've got 110 here. I've got 110 there. That's another angle. We've got 30 here, and we've got 30 there. So what do we have on this one? We've got an angle, and an angle, and we've got an angle, and an angle. Is that enough to prove the two triangles are congruent? And the answer is no. We showed that angle, angle, angle was not enough because they might be similar to each other. So angle, angle, angle is not enough information, so we can't prove congruence. All right, next one. We've got 150 here, and we've got 150 there. We've got 10 degrees here, and we've got 10 degrees there. And then we've got 58.5 here and 58.5 there. So this one down here is angle, angle, and then side. And this one looks to also be angle, angle, side. So since it goes in order, angle, angle, side, and then over here, angle, angle, side, it looks like it's working. Now make sure that the 10-degree angle is the one touching the 58.5, and this 10-degree angle is touching the 58.5. If it was flipped around where this one was 58.5 instead, and it was the 150-degree angle touching it, those wouldn't be congruent. It has to be in the correct order when you do angle, angle, side. But this one, yes, they're congruent by angle, angle, side. And then we can do a congruence statement. We'll say that CRD is congruent. Now, what matches up with C? F would. That's the one angle that we haven't marked congruent. So F would match up with that one. R, that's one angle because that's the 150-degree angle, so that matches up with W. Oh, that's not an F, that's a Y. Sorry, that's a Y. Where was I? Okay, so R matches up with W. Then D, that 10-degree angle matches up with B. Now what we want to see here is that CD should be matching up with YB. So let's see, CD, that's the first and last. Does that match up with YB? Yes, it does. Those two are congruent, so there's our congruence statement. All right, two more. So for this one, I've got angle, side, angle. And this one, I've got angle. This one would be 35 over here, right? So 80 and 65, that means this is 35. So I've got angle, side. Now, does this match up? Well, let's look. 150 is between 80 and 35. 150 over here is between 35 and 65. Those are not corresponding. It's in the wrong order. So even though I have two angles and a side, the order is wrong. This 150 is between 35 and 65, but this 150 is between 80 and 35. Those do not match up, so we can't prove them congruent. Last one. So 55 and 105. What does this last angle have to be? So that makes 160. Oh, so this other angle is 20. So using triangle sum, I can say that 55 plus 105 plus this angle down here, measurement of angle C, they have to equal 180. So this gives me 160. Now if I subtract 160, I get the measurement of angle C has to be 20 degrees. So now I know this is 20 degrees. Okay, so that's good, that's good. Good stuff, good stuff. So now what I've got here is I can say, okay, well, this angle and this angle correspond. This angle and this angle correspond. And then this side is the same on both of them. So I've got 105.20, 4.2, 105.20, 4.2. They're matching up. So that would be angle, angle, side. Now, if you wanted to, you could have proven by triangle sum that this was 55, and then you could have used angle, side, angle instead. But based on what I've got drawn here, we're using angle, angle, side. Okay, and so now we will do our congruence statement. So I'll do triangle ABC first. Okay, triangle ABC, A is going to match up with C on the other triangle because they're both 20 degrees. So C has to come first. B is matching up with D because it's 105 and 105, so D comes next. And then 55, this angle here is going to match up with this one because it's probably going to be 55 as well. So that one's going to be on this bottom triangle, that's going to be A. And then we can see that AC, first and last, AC, first and last. So everything is matching up. That's all I got for you today. I will see you next week. Math hard. We'll go a little bit deeper into this, and hopefully, if it's not making sense now, next week we'll get you getting on there. All right, that's all I got for you. See you later. Bye-bye.